All right. I think I'm ready. All right, so the exams, they went really well. It took forever to grade, but I was happy with the results. How about you?
Oh, yeah.
Were you all okay with it? Brum, brum, brum. Could have been better.
Not bad.
Not terrible though, right? Wasn't a deal breaker. All right, so let's talk about that slip of paper I gave you, right? See that little slip of paper attached to the front of your exam? So let me explain how this is going to work. You have your name, followed by a bunch of numbers, right? Name. Then there should be a number that's underlined, right? Oh, I'm just going to make these up, okay? Then 3 numbers. Then another number that's underlined. And then another 3 numbers, right?
4.
Oh, what the hell's that last number? Oh, shit. Damn it.
You got one box that's shaded gray.
No, don't worry about the shading. Damn it. I don't know. I have to go back and look at it. I don't have it on my computer down in my office. Tell you what it's supposed to be. All right, I know the first numbers are right. So this number right now is your grade in the class right now. That's your grade right now, okay? The next number is going to be what you would need in the class, what you would need on the final exam to get an A in the class. The next number is what you would need to get a B in the class on the final exam, and the next number is what you need on the final to get a C. So for example, if this said 88, 66, and 34, then this student would need to get an 88 on the final to get an A in the class. They would need a 66 to get a B. They would need a 34 to get a C. Understand? So if this student got a 72 on the final, what grade would they wind up with? A B, right? It's not enough to get the A, but it's enough to get the B. Understand? That's if we just do things as planned on the syllabus, all right? But I'm going to offer something else to you, all right? So this is what you would need on the final, right? So everybody is going to take the same final. The final is going to be somewhat comprehensive. We will talk more about that next week, about the details of what will be on the final. It's not going to cover every single thing, but it's going to be, it's going to have a little bit of everything, all right? And I'll guide you as far as what that's going to be. It will also have what we still haven't talked about, which will be the next 3 class periods. The other option here, the way this is working, is what I'm going to do is I'm going to offer you the final. Everyone takes the final, plus something else that will cover exam 2. And what you'll do is you'll take the final and you'll turn it in, and then I'll hand you the exam 2 material part if you want it. And that exam 2 material part, whatever you get as your grade when I put those 2 together, grade them all as 1, will take place of your lowest grade on your other tests. All right? Now, let me explain what that means to you. Right now, we have done 75% of your grade is done. Your final is 25% weighted. That's if you just leave it as is. So if you have a good grade, the final is 25%. It can bring you up, it can bring you down, but it can't bring you up that much, can't bring you down too much. If I do this and I replace your lowest grade with this grade, then I'm taking away one of your 20% grades, which means now 55% of the class is done, and your final is worth 45% of your grade. So that means that if you have a very low average, you now have the potential to bring it up. Yes? How does that sound? Sound okay? Now, those last three numbers were supposed to be what you need for an A, B, and C in the class. But there's 4 numbers, and one of them doesn't make sense. You know what I think it is? You know what I think it is? Can I see yours real quick? I think I know what those numbers are. Yeah, I know what those numbers are. Okay, ignore the first one. There's 4 numbers here. Ignore the first one. Okay? These last 3 numbers are what you would need on the final to get an A and a B and a C. If you go with this format, understand? So there's 2, everyone has to make a decision. And I'll let you make the decision that day. I won't force you to. After you take the final, you will make your determination of whether or not you want to go for this or not. Do you understand that if you do this, though, you're now going to say whatever that grade is now 45% of my overall grade in the class. If you don't do that, then the final is 25% of your grade. Yeah? No questions? No?
It's risky.
It's risky. Well, yeah, I mean, but this gives you the greatest ability to bring your grade up. Right? I know that there are people who are in this situation who are not even going to think about this because there's actually potential to drop their grade way down if they do this. So they might just stick with what they've got. So we're all clear?
On that exam 2 would be related rates.
Anything on exam 2? Yeah. Yeah. Now, the reason I chose exam 2 is because I looked at the class averages, and exam 2 was the lowest one, with the exception of, I think, one person. I think one person did better on exam 2 than they did on exam 1, or something like that. So with the exception of that one person, everyone else struggled on exam 2. So this is your opportunity to show me now that you understand that material. I'm not going to test you on something you already showed me you know how to do, and somehow buff your grade up because of that. There's a hole somewhere, and you need to show me that the hole's been filled. All right, in order for me to do that. Okay. So I can move on. No questions?
Professor, with visa, how is it GPA? Is it just like if you have an A, then it goes towards you like it's not. They don't do like precise like grading, right?
That's right.
Oh,
Yeah. Like what? Yeah, there's no difference between a 90 and a 100.
okay, good.
Yep. So if you have any questions about your grade, please, talk to me after class. And don't wait till the day of the final to start asking me about your grade. I think everybody can still pass the class. I think everyone who's in here can still pass, which is good because the last class I just came from, there were like 4 people that I had to give the bad news to, that they couldn't pass, and it's past the drop date, and it's never a good conversation. Huh? No, it was college algebra. Yeah. Cal 2, I think I had to tell like 9 people. That wasn't good.
Good crime.
No, you know what? I think everyone can pass, but there were like 9 people who needed like 95s and higher on the final.
Is Cal 2 your most good now?
Most what? Failed? I had 25 people there at my last test. We started with 26. They've actually done pretty good. Okay. All right, let's do 4.5. Optimization. Optimization is using calculus to solve some problems that otherwise you couldn't solve, all right? And we did talk about this. It was a bonus question on the test. I don't think anybody got it. But I didn't expect it because, you know, people are studying for other things and not focusing on that. So optimization, we did do one example. Please go back and look in your notes. We talked about the way that you could make a rectangle have the most, least, I don't remember. Did we say least perimeter or most area or something like that? Yeah. But the whole idea is this. What we're going to do is we're going to start out with a word problem most of the time. And we're going to try and figure out if we can turn this word problem into a graph of a function. And we're going to try and figure out where either the highest or lowest points of that graph are. And that answer will represent the optimum solution to the word problem. So we're going to start, I think, with the most classic example that's used in calculus classes. And that's the farmer who wants to build pens for his little animals. All right? So the farmer and the pens. A farmer wishes to build 4 identical pens for his what? Chickens? See below. I'm going to draw a picture of this, okay? See below for the picture. Find the dimensions, or I left one thing out. If he has .300 feet of fence, how should he construct it to have the maximum what? What do you think? Area. Yeah. He's got 300 feet of fence. He wants to give these chickens some room, right? To spread their wings a little bit, move around. And so he's going to build this in a way that each of the pens has the most possible area that he can get out of the 300 feet of fence. Does everyone understand the word problem? Now let me show you how he needs to build it, all right? Because he's got kind of a unique situation here, all right? Here it is. May I erase? Yeah? Okay, so this particular farm that he lives on has this little river that runs through it. And chickens are not big swimmers, all right? So he's got this water line here. It's straight, perfect straight line, right? Here's his little river. He has a shed, huge shed, okay, this really, really long shed. And then he wants to build his pens like this. He does not want the edge of the pens to come past the edge of his shed. All right, so he doesn't want this picture where the pens would be like coming way out. Oh, was it 3 or 4? It was 4, I'm sorry. Thank you. He doesn't want the pens to extend past the shed. Does that make sense? He doesn't want that. And I should probably let you know that his shed is 60 feet long, just so you know. All right, so he doesn't want that situation. It's a pretty long shed, huh?
What if they're flush with the shed?
What do you mean? Oh, that's okay. If they're flush with the shed, that would be okay. All right? Any questions as to the picture? All right. Now, the goal, right, here for us is to try and figure out the dimensions of this, right? We want to use all 300 feet of fence. We want to get the most area out of this we possibly can. So what we need to come up with is what we call our objective function or objective equation. So we're going to find the objective equation. This is the equation which contains what we are trying to optimize. And when I say optimize, I mean find the max or min of. And in the word problem, I think that I was clear on what it is we were trying to find. Was I? How should he build it, or how should he construct this, the pens, in order to what? What did I say? Have maximum area, right? Area? So our objective equation should contain the area of these pens. So I need to come up with some equation that somehow represents the area of this here. Well, I can't do that unless I start labeling this thing with some variables, right? You're going to have some flexibility here on how you build it. You could make these lengths here, which are all the same, right? Those lengths, you could make them all very, very short, but then that would make this side have to be very, very long, wouldn't it? So you could have very, very short pens that were really wide, or you could have very, very long, deep pens that were very narrow, couldn't you? Yes? And since these things can change, these dimensions, I should give them variable assignments, assign variables to them. All right, so what would you like to call this distance here, 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 here? You want to call it L? Okay, call it L. Capital L? So L is that length, L is that length, L is that length, L is that. How many L's do we have? 4. We don't need one here, do we? Because I'm going to use the shed as a boundary for me, all right? Also, I'm going to have these lengths right here, which are all the same, aren't they? Because these the pens have to be identical. That was stated in the problem. So what would you like to call? We can call this something, or we can call the entire distance something. It's up to you. W, just from here to here? Is that okay? Call it W?
Yeah.
How many W's will you have?
4.
Just 4? 1, 2, 3. These 4? 1, 2, 3, 4? What about this edge here?
Still need it there.
Well, these chickens don't. Okay, so I was saying about these chickens, they don't like water. I mean, like they won't even touch it. They just go drink and that's it, right? In this particular situation, all right? So the water is going to serve as one of our boundaries. And this is stuff that has to be clarified before you can move on. Because if you need edges here, then that's going to change how you build it, right?
Well, I mean, what if there's alligators in there?
That's right. You know, this is not a very responsible farmer. He doesn't care, really, all right? So we have 4 W's here. So now let's try and find this objective equation. It's an equation which contains what we are trying to optimize. So can you tell me what the area is?
Do you mean like 4 times width for there?
For, yeah,
4L for
4L
times 4W.
4L times 4W. So do you want to try and find the maximum area of a single pen or all 4? Or does it matter?
It wouldn't matter if
They're all identical. So you need to determine right now, do you want to tell me what the maximum area is of the whole thing or just one? If you tell me just one, then the area of the whole thing is 4 times that, right? So you have some flexibility here. So what would you like? You want to find the maximum area of the whole thing or just one? Just one?
Well,
It's up to you.
well, then it would be a little bit more difficult to incorporate the 300 feet of fence.
Will it?
Which one would be
I
harder?
mean, yeah, because you don't have 300 to spend on just one, so you'd have to divide that by 4.
Well, we're going to see how we're going to bring the 300 in. We are going to bring it in. It's not. It actually will not matter which way we do it. If you want to find the area of one pin, or see, look, if I find the dimensions that give me the maximum area of that pin, that's the same dimensions as that pin, that pin, that pin. So that would be the maximum area of the whole thing, right? So it doesn't matter if I look at just one or the whole. I'm going to do the whole just for fun. All right, just. So the area of the entire enclosure, everything, all 4 together, would be what?
4L.
Length times
Plus
4W.
What's the area of that whole thing in here? It's just this side times this side, right? That's all it is? Length times width. But here it would be this times this. So L times 4W, which is the same as 4LW. Yeah? That's the objective equation. The next thing we need to do is to write objective equation as a function of a single variable. So right now, in order for me to tell you what the area of this enclosure is, the whole thing together, I have to know 2 things, right? I have to know what L is, and I have to know what W is. If I know what L and W are, then I can tell you what the area of that is, yes? What we'd prefer instead is to somehow rewrite the area. Was this the dead one? We want the area as a function of a single variable, either L, or we want the area as a function of W. That's what I'm saying here. Why would we want to try and figure out what the area is in terms of a single variable? Why would I want to do that?
To make sure that I did it.
Why would I want to turn an equation into a function of a
So you
single?
can graph it.
So I can graph it. So I can figure out where it's highest and lowest, right? If I could graph that function, couldn't I tell you where it's the highest? I could tell you what L makes that area the highest. Or if I do it this way, I could tell you what the W is that makes the area the highest. Understand? We have A right here depends on 2 things. I want to try and make A depend on 1 thing so that it's like Y depends on X. Here, same thing. A depends on L. But to do that, there's no way I can get rid of the W or get rid of the L unless I have something else to work with. But I do. There's something else given to me in the problem that I haven't used. What is it? How much fence I have, right? How much fence I have. And that equation that was given to us in the problem, or that piece of information, is known as the constraint. Right? So my goal is to try and get this to happen, right? To come up with my objective equation as a function of a single variable. I'm going to note that my constraint is in the problem 300 feet of fence, right? 300 feet of fence. I need to turn that into an equation. So tell me what the 300 is here. When I put this whole thing together and I build it, 300 should be the total, what? length of all of these together, right? How could I write that algebraically into an equation? How many L's will I have when I build this?
4L.
I had 4 L's plus how many W's? 4 W's has to be equal to 300, right? It can't be equal to 350 because I don't have 350, do I? It can't be equal to 100 because then I've got 200 feet of fence I'm not even using, which means maybe I need to not be a farmer anymore, right? If I'm trying to use 300 feet of fence but I only use 100 of it, like that wouldn't make sense. So I need this to be equal to, I need to use all the fence, don't I? This is what we call our constraint. The objective equation normally contains 2 variables that you don't know. So you have your dependent variable A depending on 2 variables here. We cannot turn this into a function of a single variable until we have a constraint, because within the constraint equation appears those 2 variables, don't they? And if I have your 2 variables L and W in an equation, can't I solve this for L or W now? Yes?
Yeah.
So that's what I'm going to do. I'm going to solve constraint equation for L or W. It's my choice. It doesn't matter to me. What do you want? It's actually, the algebra is going to be exactly the same for both. So what do you want?
L.
You want to go for L?
You divide everything by 4.
You could do that now or later. It's up to you. If these weren't multiples of 4, then you would bring the 4W over first, right? You do that, subtract 4W, and then you would divide by 4. And we get lucky here because when we divide everything by 4, 4 goes into 300, does it? What is it? What? 75 minus W. We got lucky that that's a nice number. Okay. Everyone's with me? No problems? Sure? Now, what am I going to do with that? I'm going to come back to this objective equation, and I'm going to replace L with 75 minus W. So I come back here, and I'm going to write A, but watch how I write A. Instead of A, I'm going to write A of W. Sorry, we're replacing, we're replacing it with 4 times, what do we say L was? 75 minus W, and then times W. So that's this equation rewritten. This side's rewritten with L being 75 minus W. Now notice that the entire right side has just W's in it now. Therefore, the area is a function of W, isn't it? And I'm going to clean this up. A of W equals, let's see, what's 4 times 75? 300. And then 4 times negative W is negative 4W. And then you have to hit everything with another W. So you're going to get, what, 300W minus 4W squared? Yeah. This is a function of a single variable, isn't it? I could have, if I wanted to, just to kind of illustrate what we've done here, I could say just erase everything we've done. Okay, don't even think about the farmer anymore. I could say here's a function, right? F of x is 300x minus x squared. That's what we got here, right? We're just using different variables. And so the question now is, what W makes that the biggest, right? So how would you like to go about that? Uh-huh.
Maximum.
Right, we want to find the max of that. Okay, so we just set it to 0, but remember there was 2 methods for finding maximums of functions. There's closed interval method, and then there's when it's not closed, right? We need to determine right now whether or not this is a closed interval.
It's close because you can't have less than 0, but you can't have more than 300 either.
Okay, so let's take a look back at our geometric picture, okay? Which I've erased, but here was my river. Here were my pens. Here was my shed, right? That was it. W is our variable, right? W, it was this distance right there. Is there a smallest value that W could be?
Yes,
Okay, what would it be?
size of a chicken.
That's a good answer. Yes, but these are theoretical chickens. So there is a smallest value that makes, I guess, some sense. It doesn't make sense, but it is definitely a smallest value.
0.0001.
How about 0 itself? How about 0? I mean, 0, we wouldn't even have a pen, would we? But it's not going to get smaller than 0. Do you agree? Now, you have to be extremely careful with this. If W is 0, then that means all of your fence would be here, 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 right? Do you agree? So if W is 0, that means your 4 L's have to be the 300, don't they? Which means that each L has to be what? 75. Uh-oh, what's wrong with that? Goes past the shed. Right? It goes past the shed. So W can't be 0, because if W is 0, then the 4 L's together add up to be 300. They go past the shed. Now, I agree, we're still not making frickin' pens because they're 0 wide. But algebraically, we are not allowed to let L be 75. So maybe we should go about this the opposite way. What are we allowed to let the 4L be equal to? So this is no, right? Can't go past the shed. So we are allowed to let the 4Ls be equal to, I'm sorry, not the 4Ls. We are allowed to let an L, the most the L could be would be what? 60. Which means that 4 L's would be what? 240, which means we have how much left for the W's?
60 feet.
So we have 60 feet left for the W's. And how many W's do we have? 4 W's. I hope you're following the logic here, okay? Because I'm not writing any of this down, I'm saying it. The barn is restricting our length here to be 60. There are 4 of them, which means we would at most use 240 feet for the 4 L's, which leaves us 60 feet left of fence. That 60 feet must be made up of these 4 W's. So the 4 W's are the 60, which means that W, the smallest it could ever be, would be what? 15. That's the minimum W we can use. All right? Remember, what I was trying to do is see, is this on a closed interval or is it on an open interval? I'm saying the smallest W I'm allowed to use that makes sense in the problem is 15. Now, is there a largest W? What would it be?
Well, that would be if you made L 0. Right?
That would be if you make L 0. And that means that you would use all 300 feet of fence for this side, and then try and build these and say, oh crap, I don't have any more fence. So if I let this be all 300, right, then that means my 4 W's would have to be equal to the 300, which means W would be what? 75. And that's okay if W is 75, it's just not okay if L is 75, this length. That would be the maximum, right, that I could have? The maximum W we can use. So is this function that we're about to find the maximum and minimum of, is it on an open or closed interval? Is there a restriction on W?
No. Oh,
Yes.
What's the smallest it can be? What's the biggest it can be? So we're looking at this on the interval, what, 15, 75? Do you see that? I have a continuous function defined on a closed interval. I need to know if you're following this or not. I mean, do you have any questions?
Makes sense.
How would you find the maximum value of a function on a closed interval? You take the derivative, right? You find the critical numbers. So let's find the derivative. So I think when I first got to this, I asked everyone, like, how do we find the maximum of this? And everyone was like, we're going to take derivative, right? But do you see there was a lot that we had to kind of think through to determine if we were on a closed interval or not? Like there was a lot more to get this part. On your test, I just gave you it, right? Here, it's a closed interval. Now, so, oh, our derivative is beautiful, isn't it? So easy to work through. Is that it? 300 minus 8W? Set that equal to 0. Notice I'm using A prime instead of F prime, and that's 300 equal, or minus 8W equals 0. So 300 equals 8W. What is that? It doesn't go in there evenly, does it? Let's not get a decimal. Let's try and leave it as a fraction for now. So what's 300 divided by 8 when we reduce it? So 75 over 2? 75 over 2, which is what, 37.5, right? I'll write it as a decimal also, but you should be able to have it as a fraction too. All right. That's a critical number. Do we have any other critical numbers? We have to look at where the derivative is undefined, right? Where's the derivative undefined? Not going to happen because it's a polynomial, right? The derivative, sorry, is a polynomial. It's nice. Never going to be undefined. So this is the only critical number we have. What now?
Plug them in the original function.
This is the closed interval method. So plug that answer in and the endpoints. We already know the endpoints are going to give us ridiculousness, right? But we're going to do it anyway. And where are we going to plug them in? To the original function right here. Well, no, it may not give us ridiculousness. Hold on, let's see. All right, we need A of 15. We need A of 37.5. And I need A of 75. Now, it was important that our critical number, right, 37.5, lived in this interval, right? If it did not live in this interval, then I would not consider it, right? So let's try A of 15. A of 15. So that's 300 times 15 minus 4 times 15 squared. And if someone could please do that on their calculator.
3,600.
What is it?
3,600.
3,600? That would be the area if we built it that way. Now do 37.5. What did you get? 56.25. Anyone else? Yeah? I want on that one at least one more confirmation. I guess I'm going to have to.
5625.
Yes? 5625?
Oh, yeah, I put 56. I said 56.
You said 56, I wrote 52.
No, sorry.
No, I think I messed up. 5625?
Yes.
Okay, and then what about 75?
0.
Yeah, it's 0. You can tell right here. You can tell right here, because this we cleaned up and turned into this, but if I plug 75 in right here, it goes to 0. So, can you see, obviously, what the biggest is there, right? So let's summarize everything. To get a maximum area of 5,625 square feet, right? We measure area in square units. To get a maximum area of 5,600 or 5,625 square feet, the pens should be what? What are the dimensions of the pens? So go back to your picture. This was L and this was W, was from here to here, right? What does the 37.5 represent? The width, right? That was W. So the pen should be 37.5 wide. And how long is it going to be? Is it the same?
Yeah.
How are you getting it, though?
37.5 times 4, and then half that from 300.
Okay, you can do that. Go back into your work, though. Did we ever solve for L?
Yes.
We did, didn't we? Remember when we had the constraint equation and we solved it for L? That's where you can plug the W back in. Or you can go through all the thought process, but sometimes later in harder problems it's more work. So what is it, L? I'm going to write up here. L was 75 minus 4W. Is that what it was when we solved for L, right? So just plug 4 times this in here. Was that it? No.
No,
It was just W. Yeah. Okay. So you plug that in, this in here, and you get L is the same thing, 37.5. And, pardon? And through long. Yeah, each of these pens would be squares. But I'm telling you right now, it's only because of the way we built it, all right? And only because the only thing that saved us from and made this squares is the river, and more importantly, the shed. Because if the shed wasn't there, we would have had a 5th side over here. We would have had 5 L's instead of 4 L's. And then they would not have been squares. And that would be something you would have to figure out in a different sort of word problem. All right? Understand how that all worked out? All right, so the more traditional farmer pen problem is not that kind of complicated with the river and the shed. A lot of times they'll just give you, like these pens are going to be sitting out like this, just in the middle of a field or something. And, you know, you have 300 feet of fence. What are the dimensions here? So imagine the same problem with that picture. Do you think you could do that? 300 feet of fence, find the dimensions? Okay. Let's try something else. Man, I can't believe that took us like 45 minutes. I really kind of took my time through that. How about this? Find the point on y equals x squared plus 1, which is closest to the point 0, 2. Now this is not like a farmer word problem, but it still is an optimization problem. And after we do it, I'll talk about why you would ever want to do something like this. So what I'm going to do is I'm going to draw a picture of what we've got here. X squared plus 1 is a parabola, right? Opens up, moved up 1. X squared plus 1 looks like this. Shoot, I don't want 0, 2. Sorry, switch this. That's too easy. Oh, actually, that would have been hard. Never mind. But I'll switch it to 2, 0. The point 2, 0 is somewhere around here. I want you to tell me what point on this parabola is closest to that point. You understand that? Is it this point? This one? Somewhere in here? Where? Exactly where? What is it? Understand the question? All right, that's it. So let's do it. What do we start with? What did we start with in the last one?
General equation.
Okay, which we called the
Objective.
the objective equation. Okay, what's the objective equation? What is it that you're trying to find the maximum or minimum of here? So are you trying to find a maximum here or a minimum? The point that's closest to this has the smallest distance from this point, doesn't it?
Yeah.
So would you agree that I need a minimum distance? Yes?
Yeah.
Trying to find a minimum distance. So my objective equation involves the minimum distance between the curve and the point 2, 0. Yeah? I'm just thinking, I'm trying to come up with the objective equation, so I'm writing down what it is I'm trying to find the maximum or minimum of. I'm trying to find the minimum distance between the curve and that point. So can we actually come up with an equation that represents that distance? If I go from this point to some arbitrary point on that curve, like that, that doesn't look like the point that's closest, does it? No? But can you come up with an equation that represents this distance, which I will call d? So if I call the distance between these 2 points d, don't we want to know what makes d the smallest? Yes? What makes d the smallest?
Isn't there a distance formula?
There is.
And is that what you would use?
Sure. Just has to be an equation that gives me the distance between these 2 points, right? So d, I want, now that I've drawn that, I want to minimize little d over there, don't I? I want to find how I can make d the smallest possible thing. But the key is that point right there cannot be anywhere. It's got to live on that curve, right? And this point right here is always stuck at 2, 0. So now, using what you know about distances, what is the distance between 2 points? So recall from a previous class, not this one, that if someone gives you a point x1, y1, and someone gives you another point, x2, y2. The distance between them is?
Y2 minus Y1 over X2 minus X1.
Yeah, I'm out of space here. The distance between them is y2 minus y1 squared plus x2 minus x1 squared square root. Does that distance formula look at all familiar to you?
Yeah, from like geometry.
Yep. Does anyone remember where it came from? Draw a right triangle. What's the distance from here to here? That's supposed to be a brace. Isn't that the difference between the y-coordinates? What's the distance from here to here? Distance between the x-coordinates? Distance from here to here is d. A squared plus b squared is c squared. So this squared plus this squared is that squared, but then you take the square root on both sides and you get this. All right, that's something else. All right, so this is it, right? This is it. This is it. This is an objective equation right now, yes? But there are some major problems we have with this objective equation. It has like 4 different things we don't know. y2, y1, x2, x1. Do any of these things, are there anything that we know about these things?
Well, we know one set of x and one set of, or one x and one y.
Okay, I know that one point is always what?
0.
Okay, so I know I could call the point x1, y1. I know that that one could be called 2, 0. Agreed? And the other point, x2, y2, isn't just any point living out there on a flat sheet of paper. It has to be a very special point. What does it have to be? Hold on. We are going to find the closest. I'm just trying to find this point has to live on this curve, right? If it lives on that curve, do you agree that there is a connection between the x and y coordinates? If I call the x coordinate x, what must the y coordinate be? X squared plus 1. That point lives on that curve, doesn't it? We say xy usually, right? But what's y? Y is that distance. So if you pick an x, the y is how high it is. Do y'all see it? So like, of course, if I plug in 0, I'm at 1. If I plug in 1, I'm at 2. If I plug in 2, I'm at 5, right? But there's a relationship between those points, and there's the relationship. The distance between that point and a point on your curve is this formula with those values plugged in. Can we plug them in? You ready? Let's do it. So the d that I'm looking for is square root of, okay, y2, which for me is what? X squared plus 1. Then minus y1, what's y1?
2 or 0.
Minus y1, which is 0, and then that quantity squared, plus x2, which is x, and then minus 2, and then squared. Which I didn't need that 0 in there, so I'm just going to put x squared plus 1 squared plus x minus 2 squared. Now, we want to have an objective equation, right? It has to contain the thing we're trying to find the minimum of or the maximum of. Do we have an objective equation? Do we have d is equal to something? We've had it for a while, right? We then want to try and get our objective equation into an objective function where it depends on only one variable. Does this depend on one variable only?
Yes.
Yes. See, we've come up with a formula where if you tell me an x value, give me an x, I don't care what it is. If I plug it into this, that'll give you the distance between the point 2, 0 and that point. That's the formula for it. And I want to know what x I plug in that would give me the smallest value. Right? So my constraint, like in the previous problem we had a constraint, didn't we? I don't really have a constraint equation. The true constraint in this problem was the fact that this point had to live on that curve. It wasn't just some arbitrary point in space. This was our constraint. All right, so let me write down again up here where we are. I can now write my objective as an objective equation as an objective function of a single variable. And I'm trying to figure out where that is the biggest or smallest? Smallest, right? So if I want to know where that's the smallest, what is the next thing I need to look at?
You look at this open or closed interval.
Is it an open or closed interval? Well, what do you think? Do you have any restrictions on x? And what is x here in my picture? What is x?
This one x has to be positive.
It's the x coordinate of that blue point, right? Is there any restriction on where that point can be?
No.
Not really. I mean, I could come over here and pick a blue point over here, right? But then I would tell you you're crazy, right?
Yeah.
So even though algebraically there's really no restriction on making x go this far or this way or that way, I could be way up on the parabola up there. Realistically, could we all agree it's between two things? Maybe we can figure out what it's between? What do you think? 0 here? And what do you think the biggest value it could be would be? 2? Does that seem reasonable? Because if you're a 2, you're up here on the parabola, and that's definitely, there's something in there that's closer, yeah? So why don't we restrict this to a closed interval? 0, 2. I think that's safe. Is that all right with you? And now, yeah, the derivative. Now I'm going to put a little asterisk here because most textbooks will tell you that because you have a square root there, what you can do is you can define a new function to be this squared and it'll take care of the square root, and you can find the minimum of that function, and then whatever that minimum is the same here. I'm going to not do that because I want us to prove to ourselves we can take the derivative of that. All right? So let's take derivative of it. D prime x. So we have chain rule here, don't we? A lot of it, too. What is the derivative of the square root of something? 1 over 2 root of all this junk in here, right? May I call it junk? And when I say junk, I'm referring to all of that as being the junk, right? All right. Then, chain rule times the derivative of the inside. And so when I take derivative of the inside, I have an addition. So I'm going to do this one, then I'm going to do plus, and then this one. So take derivative of that, you're going to have to do another chain rule, right? 2 is going to pop out. You'll be left with x squared plus 1 times 2x. Are we done with that derivative? So that's the derivative of this. Plus 2 times x minus 2 times 1, which I don't need. And don't forget, all of that was in a parenthesis. Now, as bad as that looks, it's not that bad, all right? So 2 over the square root of junk down here is still there, but the top should clean up. Let's see if we can clean this up. Let's see. 2 times 2 is 4, 4x, and then I'll distribute that through the parentheses.